Okay, so you've been working with some different ideas in calculus, right? You've been working with finding the gradient, right? The slope of lines. You've been working with just differentiating functions. That's going to go on the video. That's going to be nice. All right. And today what we're going to do is we're going to continue along those lines. We're going to talk about some of the ways you use calculus to be able to actually solve problems. We're going to look at kinematics. So in other words, what does that mean? Anybody know? Motion. Yeah. So we're going to talk a little bit about some issues with motion and how you can solve problems with motion. Okay? What happens when you move? If you're walking, you start at one point and then what? You're moving. You're going to another point, right? So we're traveling over a distance. So the first thing I want to do is I want to talk a little about some of the terminology and some of the symbolism for this. Because, in math, we can't just use the word distance. We've got to be able to give it something smaller so that you don't have to write the word distance all the time, right? So we're going to talk a little bit about those first. So if you have your book, then you can follow along. It's on page 67. If you don't have your book, don't worry. Anything that I expect you to have to remember, I will write down. I'm not ever going to just say, oh, remember this. All right? Okay, so first thing we want to talk about is that when you walk, what happens when you walk a longer time? You're going to go further, right? Slow down. Okay, so we're always going to have T standing for time, right? No stretch there, okay? And when you're walking, and generally, the time units that you're going to use are seconds. Okay? So we have the letter or symbol that we're going to use. We have what it stands for. And then we have units. And do not forget that a problem in calculus or any higher mathematics is not correct unless you have units, right? So you've got to have your units or it's not right. So time, that's an easy one. The next one we're going to have is S. And most people would say S must mean speed, right? It's not. Okay? S stands for distance. Clear as mud, right? But can't be D because differentiation. So we got D. It has to be something, so it's S. So don't think of it as speed. It's the distance. And for us, we're going to measure those distances in meters. Took all I had to be able to put the R before the E, but there we go. So, all right? Sorry, it just moved me. Okay? Now, when you think of speed, think of like driving a car, right? When you're driving a car, or you're riding in a car, you go speed. How is that speed measured? In kilometers per hour, usually, right? Right. So it's always given as some measurement of distance and time, right? So distance and time, and that's called velocity. So V stands for velocity. And it's really important that we know these terms. And velocity simply means the change in distance with respect to time. Change with respect to, does that sound familiar in calculus? That's a differential, right? Change in y with respect to x, right? That's what you're doing, is measuring the change in y given certain constraints in x. So velocity, therefore, what do you think you're going to do to find velocity? Differentiate, exactly, because it's a change with regard to time. Excellent. And then finally, and velocity is measured in meters per second. Okay? Now, and we also have something called acceleration. If you're going a certain speed, does that mean you have to stay that speed? No, you can either go what? Faster or slower. And either one of those, it doesn't matter if it's faster or slower, is acceleration. So acceleration is the change in velocity with respect to time. So you could be going one speed, but then you change again. So that's a second change. So what do you think you're going to have to do to find it?
Differentiate.
Differentiate a what? A second time.
The second derivative.
Right? So we're going to find the second derivative, exactly. How easy is that? So note, the math here is not going to be new. It's just the way you use it that's going to be new to you. So that stands for acceleration. And it's always given in meters per second squared. Okay? And you'll see formulas that start off with meters per second squared, so you'll know that's talking about an acceleration, like a rocket being fired, right? Okay? All right. Now, those are our terms, but we need to know a little bit about being able to work these because we already instinctively know some information. If you think about what happens when you first begin a task, how many seconds or how much time has gone by when you just start? Zero, right? So in the beginning, okay, t is 0, right? And it's going to be important to know that because we're going to have to plug numbers in place of these letters to be able to solve the problems that we have, okay? Now, and if you're leaving to go somewhere, how far have you gone? Nowhere. So we're going to give that a number as well. We're going to say that at the beginning, s, the distance, is also equal to 0, right? And you should be comfortable enough with these. You need to study this enough and read these enough so that you're comfortable if I use the word distance or if I use just the letter s, okay? Because you're going to be seeing that notation. So you need to make sure that the notation and the language is really important for you to understand. Okay? So initially, time is 0, and initially, speed is 0. Right? Now, or distance is 0, I'm sorry. Distance is 0. Now, unless they give you special circumstances, and we'll look at some examples of when that's going to happen next time when they give you special circumstances. All right? And if you're just starting, how fast are you going? Yeah, you're just not going anywhere, right? So velocity is usually assumed to be 0 at the start as well. Okay? So motion usually starts where time, my computer there, where time is 0. And the distance you've traveled when you just begin is usually 0, right? Unless perhaps you hold something up high, but we'll talk about that. And if an object can also have a velocity of 0, and there are a couple times that could happen. When it's at rest, in other words, not going anywhere, right? No velocity, okay? When it's at its greatest height, so in other words, goes and changes, so at its greatest height, so the fastest it goes. And it can also be 0 when you're finished moving, in other words, when you're stopped. Right? Okay, so keeping in mind that those things are 0 and when they're 0 is really important to be able to work these problems. So if I ask you if you're just starting, how far have you gone? Nowhere. So what number would you use? 0. When you're just starting, how long have you been doing it then? 0. And keep those in mind. You'll see why as we move forward. Okay? Now, you also need to be careful about what they're asking. Okay? If they give you a when question, what specific piece of information am I looking for if they say when? That's always time. You're looking for time. And if you're looking for time, they have to give you everything else, right? You can't solve for more than one unknown. Okay? If they give you a where question, which thing do you think that is? That's your distance. Okay? So make sure that you understand what question is being asked so you'll know which units and which things to use. How does that look? Fairly easy? All right? Well, it's very easy to do mathematically as well because velocity is found by simply using S, whatever formula you have for S. Okay? You're going to use S to find the velocity by simply taking the derivative. The differential. What do you all use? Differential?
Yeah.
Sorry. And that will give you the function for velocity. So make sure you change your V to an S. I'm sorry, your S to a V. Got that written backwards. I'm sorry, guys. Sometimes you just have to bear with me. Okay, so to turn S into V, just take the differential. Okay? And then that's going to change it. Now, is it going to mess with time? No. Time will stay the same. Then, to change V, velocity, to an acceleration, you just take the second derivative. So do the differential again.
What does differential mean?
Uh-oh. Am I using the wrong term for you?
Well, I'm just like.
Differential, take the derivative. So remember, if you had some function equals x squared plus x minus 4, or let's say 2x. So, okay. Remember, that's when you take you're taking the derivative of it. So f prime of x, you multiply times the coefficient. So 2 times the coefficient here is a 1, gives you 2. And then you subtract 1 from the exponent, so 2x. Right? Remember taking the derivative? Okay. And then here, that exponent is a 1. 1 times positive 2 is positive 2. X to the 1 minus 1 is x to the 0. So in other words, the x disappears. And the derivative of any number is always 0, right? So it just makes it go away. Okay? So taking the derivative. And did you write it as derivative of x, or did you just write f prime? Okay, good. That's the easiest notation. So that's good. Okay? So remember, to take the differential, what you do is first multiply the exponent times the coefficient. What's a coefficient? The number in front of your variable. Exactly. Good. Second, subtract 1 from your exponent. Right? Remember that? And then third, the differentiation for any number term, all number terms become zeros. And do you write a 0? Who cares, right? So you just write it as 0. And we'll look at some examples to get you back into the swing of it. Yes?
So I get how to differentiate, but then what's the is to the differential, that stuff? What do you do there?
Okay, wait, now repeat the question.
Well, it says is to be.
Right, to go from S to get velocity. If you're gonna know a function in S. In other words, it'll say the distance is equal to this function,
okay.
Right?
Yeah.
And to get from that function to your velocity function, you do the derivative, or you take you differentiate it. Okay? And we'll look at examples so you see exactly what I mean. Because remember, sometimes I'm going to be using words that you're not used to. So let's get them. So let's just look at the example that they give, so that we can walk through this and you'll have this example completely worked out. So it says, example, a rocket is fired into the air, right? So we know it's going to be moving up, yeah? So rocket is fired into the air. The relationship between its height in meters above the ground at the time in t seconds it was launched is given by the function h equals 1 plus 60t minus 40t squared. Okay? So they're going to give you some function. Now what we have is its height. And height is a type of what thing? A distance, right? So h, s, same difference, but we're talking about a height here. We want to know how far above the ground was the rocket when it was launched. So when it was launched, How high? How far above the ground? So is this a time question? Am I asking when, or am I asking a where question? Be careful, yeah. How far above the ground is going to be a where question, right? So that tells me the thing that I'm looking for is I want to solve it for h. Okay. Well, in order to solve for h, what do I have to know? Time, right? You have h and you have t. You got to know one of them to solve for the other. You can't have two variables in the same function and solve it. So we need to know the t when it's launched. Well, that's pretty easy. T when something is launched, how much time has gone by when you just do it, when you just start it? 0. So all we have to do is evaluate the function. Evaluate means just plug in the numbers, right? So we're just going to evaluate when t equals 0. So that just means replace every t with a 0, and you never, ever, ever, and I don't know if this was beaten into you before, but it's going to be now, replace a number with a letter without putting it in a bracket, parentheses, right? Because you change the entire meaning if you don't use brackets. Now, are they always totally necessary? If you don't have anything else with it, it's okay. But I would rather you err on the side of caution and use too many than not enough. Okay? So now, am I going to use anything in place of h? Nope, don't know that. 1 won't change because there's no t there, right? Plus 60 times my t, which in this case is what? 0. Minus 40 times my t, which is 0 squared. That's nice. Why is it nice when they're zeros? Yeah, they make 0 times anything just makes 0, so they're gone. So what is h? 1 potato? 1 what? Meter. Right. So our height was 1 meter. So that tells us that when they launched this rocket, was it on the ground? No, it must have been on a stand that was a meter high. Okay? So all they asked us was just to evaluate it for a specific thing. So did I use any calculus there? No, that's just algebra. Okay? Now, how far did the rocket travel during the first second of its flight? So this time, they're asking how far did it travel during the first second of its flight? Okay? So, our time is not 0 this time. Time is given in seconds. How many seconds? 1 second. So our time is equal to 1 second. So 1 is the number I'm going to use. Don't use 1s. All right? So let's just do the formula. Height equals 1 plus 60 times 1 minus 40 bracket 1 squared, right? 1 plus 60. Whoops. Okay. Negative 40. I'm sorry. 1 squared is still 1. And it's just a 4, not a 40? Yeah. Oh, I'm sorry. Thank you. I'm writing down the problem wrong. Okay. So minus 4. 4 times 1. Combine all those like terms. And what do you get? 61 minus 4 gives you 57. And it's 57 what? Meters. Okay. So okay, so right. Now, so that's the height. But what do we already know from the first part? That it was a meter off the ground to begin, so the total distance that it traveled was 56 meters. Be very careful. They're going to do that to you. They're going to drop a ball down a well, and they're going to. And if it was 0, where would you start dropping the ball if you're going to drop it down a well? At the top of it, which is the ground level, right? What if I hold it up? Is that all well? Got some going on. So be careful about. They do little tricks like that. Now, the next thing they want to know is they want to know how fast was the rocket traveling after 2 seconds. Now, is that a where or a when question? No, this is a how fast question, right? And what thing do we use to measure how fast? Well, velocity, right? So this is velocity. And remember that velocity is the same thing as taking your distance and just getting the derivative of it, right? That'll give us the formula for the function for velocity. So let's do that. So plugging that in, remember that our original function was 1 plus 60t minus 4t to the second power. So we need to find the derivative of that. The derivative of 1 is what? Zeros or nothing, right? Who cares? Here, the exponent there is a 1, so 1 times 60 is 60. T to the 1 minus 1 is t to the 0, in other words, 1, so it's gone. Here, 2 times negative 4 is negative 8, and t to the 2 minus 1 is just t to the first, or plain old t, right? Remember, you're multiplying times the exponent, the exponent times the coefficient, and then just subtract 1. Okay? Pretty easy pattern there. Make sure you remember, though, that if you get t to the 0, that's always equal to 1. T to the 1 is just equal to t, right? Okay? So our velocity, then, is found by using the function 60 minus 8t. Rocket science, right? Sorry, I couldn't resist. Okay. And we want to do this after how many seconds? 2 seconds. So t equals 2 seconds. Sorry, t. Okay? So let's plug that in. Velocity equals 60 minus 8 times 2, which gives us velocity equals 60 minus 16. 44.
MS.
There we go. Units. Meters per second.
Can we do the ms minus 1?
Okay?
Like,
Can-
instead of in yes.
It's because of physics.
Yeah.
Just do m over s. Okay? Meters per second. Now, notice that it's just 44 meters per second. We're not talking about a distance. So, and this 1 is gone. So there's no subtract 1 anymore or anything like that. You've changed the function by taking the derivative of it, right? So don't go back and think, well, now I need to subtract 1. This is different. This is velocity. It just comes straight from the function. Okay? So anything you add or subtract or whatever is going to go away, right? Because it'll be a constant. Okay? Now, looking at that same function, now that we have velocity, the velocity function, what was it, 60 minus 8t? Okay? Now that we have the velocity function, what does it say? What is the maximum height reached by the rocket? Okay? So, we have to find out how we can find the maximum height for this rocket. Sorry? What do we know about velocity at its greatest height? Yeah, so velocity at the greatest height becomes 0, right? That's one of those points where velocity becomes 0. Okay, so if I put 0 in place of the velocity, I can now solve for what? Time. Okay, so subtract the 60 from both sides, or you could just subtract or added the 8t. Which would you have done probably? Add the 8t to get rid of the negatives? Does it matter? No. Okay. But get your t's on one side, your numbers on the other. That gives you 8t equals 60. And yes, I'm sorry, I will do every step of the algebra all the way through, so I'm sure you're sad. It's not going to kill anybody, is it? All right. If you have the answer 20 minutes before me, that I understand. Then that's 8 times t. The opposite of multiply is divide. So you divide by whatever that coefficient is. And 60 divided by 8 gives you 7.5, and time is measured in seconds. So the maximum height is reached after it's been in the air for how many seconds? 7.5. Now, but they want to know what is the maximum height. Well, this is not a height, that's a time, right? So how could I find the height given the time? I have to go back to the height equation, right? Okay? So is that that's not one of the derivatives, it's one of the others. They're really dragging you through a knothole here with everything they can. So the original function was 1 plus 60t minus 4t squared. Plugging in our new time of 7.5. Height equals 1 plus 60 times 7.5 minus 4 times 7.5 squared. You do the math. 160 times 7.5. I'm always going to make y'all do the math, by the way, because I've got a degree. Sorry? 450. Okay. That's going to be negative. 7.5 squared.
225.
And then times 4 is
225.
Is what?
Is 225.
225. All right. Excellent. Okay. Now all we need to do is just combine all of those. So 450 plus 1 is 451 minus 225 is 226. Okay. So what is the maximum height that it reached? 226 meters.
Is that one question?
Yes.
For the next one.
Okay. Now, it's not finished though. What if it asks when was the velocity equal to 12 meters per second? So what are we looking for? Okay, so when was the velocity equal to 12 meters per second? Well, what thing is measured in meters per second? You bet. So what we can do is plug it in, and they want to know when. So when is a time question, but it's velocity, so we're not going to go back to the h function. We're going to use the v function, right? Which is what? 60 minus 8t? Thank you. No memory at all. Can you believe that? So where am I going to put that 12? In place of the v. There you go. All right. Get all my numbers on one side by subtracting the 60 from both sides, right? Because I want to leave my t term by itself on that side. So 12 minus 60 is?
48.
Negative 48. Excellent. Equals negative 8t. That's negative 8 times t, so the opposite of multiply is divide. So I'll divide both sides by negative 8. The negatives will divide away. What's 48 divided by 8? 6. Over here, the negatives and the 8s will both divide away and gives you t. So 6, what? 6 seconds. So t is equal to 6 seconds. How's it look? Tedious? Long? You hate it. She's got this look on her face like, okay. Okay? So, which one didn't we do? We didn't do one bit more part of it, though, right? The acceleration. So, let's look at that one. Acceleration, it says, calculate the rocket's acceleration after 2 seconds. Well, acceleration is found by taking the derivative of v, right? So, it's the same as the second derivative of h. So, we have v. 60 minus 8t. So taking the derivative of that will give us our a. Derivative of 60 is 0, so it goes away. 1 times negative 8 is negative 8. So there you go. The acceleration is negative 8 meters per second. There was nothing to solve there because we didn't have anything but a constant, right? So acceleration is negative 8 meters per second. All you do is just take the derivative again.
If there was a t there, what would you do? This is having 3 meters per second speed.
Oh, sorry. Thank you. Sorry. The wrong units. Good eye. Okay? Yeah, if there was a t there, then the derivative would be different. But
What do you work out?
doesn't happen. Most of these are going to start out quadratic and then drop down. Yeah. Then they'd have to give you more information, right? What if there was still a t left in your formula? You'd have to have a time in order to do it, right? So you'd still have to be given more information. Okay? But at maximum acceleration. Okay. Now, so what we're going to do is, some of you don't have your book, right? So what we'll do is, I'll tell you which number this is, but I'll also just write it down for you so that those of you who don't have your book can do it. We'll do it in stages because I want, now that I've done a few, and you've seen some done, I want you to do a few. It's not fair? Is that not the usual way this world works? Yeah? I show you and then you have to do it, right? Okay? Keep in mind which pieces are which, okay? So, there's another nice long problem on page 69 that has, what, A, B, C, D, E, F. So exactly the same number of pieces that we just did, and they're exactly the same ones, right? So you're going to be asking the same questions. Try to think of the rules, okay? Here's one thing that we do wrong as math students, and I want you to be aware of it. We try to learn from examples. If I showed you building a house, does that mean you know how to build a house? Oh, kids. Okay, so you've walked down the street and you've seen one of those gigantic cranes operating. So you saw it work. Does that mean you can now operate it?
Yes.
Baloney. All right? It's not good enough to see something. You have to follow the directions to learn how to do something, right? Now, can you do a complicated task if you have it all written down and you can do it first step, second step, third step, whatever? You can give it a better shot than if you just saw somebody else do it, right? Okay? So keep that in mind when you're learning these. Too often, we try to just look at the example and figure out, okay, well, here's what he did. This is what I need to do, right? If you want to get the velocity, there's a series of steps. First, take the derivative, the differentiation, right? Okay. If you're looking for time, then they have to give you the height or one of the other values. Okay. So make sure you know what it is you're looking for. So identify what it is you're looking for and which thing you have to do to get there. All right. So here we go. Question 1 on page 69. It says, Allison throws a stone vertically into the air. The relationship between the height of the stone in meters and the time in seconds since she threw it is given by h equals 2 plus 20t minus 5t squared. Now, I like it that they give you one that's exactly the same thing so you can be prepared for it. What I don't want you to do is just follow the steps by looking at what we did. I want you to follow the steps based on the ideas, right? Okay, so the first one in A, they want you to know how far was above the ground was the stone when it left her hand. How high when it left her hand. Now be careful, is this a where question or a time or a when question? Where, exactly. It's how high. There you go. We know when, right? When it left your hand up. Sorry.
Last year we learned that in the a squared plus b squared equals c squared sort of thing. The c was how high it was started. So could we just look at that and go?
You bet you can.
We can just write down.
In this one you can. Why? Why can you do it in this end? You can this time. Why? Because the time is equal to what? 0. Yes. So there's no math to do here, really, right? Okay. All right. So the time is 0, which means that anything with a t in it is simply going to disappear, and that's what's left. Right? Excellent. Okay. So how high was it? Anybody? 2 meters. Right? So in other words, she's got it in her hand, so she's not laying on the ground. Sorry about that. Woo-hoo. So she's not lying on the ground, right? She's standing up when she throws the stone. And if you're standing up, then you have some height. Okay, good. How far did the stone travel during the first second of its flight? Go and see that. How far in 1 second? Okay. I'll give you... Sorry? Okay. Quick like a bunny. Should take a minute or maybe less. Everybody got an answer? Pardon me? Oh, I haven't done it yet, so I don't know. I'm not sure. Okay? Y'all are going to get so used to that. I like timers. I can change the tone, the ringtone, if y'all like it. You like the little soft, easy one? It's a very peaceful way of telling you you're out of time, isn't it? Okay, so, right? Who wants to tell me, what is it am I looking for? Is this a when or a where question? This is a where question, right? We're asking how far it's traveled, so we're looking for where. In order to solve a where question, you must know the time. And that's exactly what we know here. So what we're going to do is simply, everywhere there's a t, we're going to put in what number? 1. We like it when they use ones. Makes it very easy for us, right? So, everywhere there's a t, all I did was replace it with a 1. And now let's do the math. 2 is not going to change. Positive 20 times a 1 is positive 20. 1 squared is 1 times negative 5 is negative 5. Right? Go through that pretty quickly because y'all can do that in your calculator. As long as you're very careful, make sure you watch your signs. I know you all are using calculators. It's perfectly fine. Now 20 plus 2 is 22 minus 5 gives me 17 what? Meters. Because all our answers are meters. Why? You bet. Because remember, it says before it even goes anywhere, it's already how high? Right. So minus the 2 meters gives us what? 15 meters of motion. Right? Because it was already 2 meters high before it ever began. So be careful if you do that. If they do that to you, they're always going to give you this first question as how far does it go? How high is it before it does anything? At 0.
I differentiated and it got 15.
Okay.
That's not the right way.
By plugging it in, because you did. If you differentiate that, you're going to get a velocity, and which will tell you how far in a certain amount of time by the speed. Don't do that. It won't always. It just depends on the problem they're working with. All right, how far was the stone traveling after 1 second? Or how fast? I'm sorry. How fast? Now you're going to differentiate, right? After 1 second. Okay, this is C. Now, is this a when or a where question?
How fast?
No, this is a how fast question. And what's the how fast thing? V. So we need to get a new function in V before we can answer this question. So first, just differentiate it for me. Get me a V. Okay, well, hold on. Yeah. Hold on a minute. Let's give everybody a chance to catch up. Hold on a second. Let's give like 30 seconds or so. Everyone have a chance to get the V. Right? How do you find V? You differentiate the H function. I love it. They give you S for distance, and then they use H all the way through. But because it's a specific type of distance. All right. Okay. So there we go. So you've got the differentiation. What you need to do is and you're going to get V equals what? Anybody?
20 minus 25 t.
25.
25. 5 is sweet. Oh, wait, no, wait.
Do we agree?
5.
No.
Maybe that's right. 5t, sorry.
There you go. Okay. 20 minus 5t?
Yeah.
Okay. Do you remember? So you get H. What was our original function? H equals 2 plus 20t minus 5t squared. So let's do that. So 2 is just going to go away. It's t to the first. So 1 times 20 is 20. T to the 1 minus 1 is t to the 0, which in other words turns into a 1. 2 times negative 5 is negative 10, and t to the 2 minus 1. There you go. So there's our function. So that should be a 10 there, right? And so negative 10. Okay? It's all right. Now, that's our velocity function, right? So all we need to do is plug in what in place of t?
1 second.
So just plug in that 20 minus 10 times 1, which gives us velocity equals 20 minus 10, because 10 times 1, of course, which gives us a velocity after 1 second of what? 10 meters per second. Excellent. Okay? Okay, just take your time. Be careful with it. The math here, super simple, isn't it? But it's knowing when to do what. And that's how to study for it. Know when to do what. All right. Let's look at the next one. Calculate the stone's acceleration after 1 second. So this time, we want the acceleration after 1 second. Go. You guys got the answer? Ladies?
Sorry.
Okay. All right. So acceleration, do we use the h function?
V. Oh, wait.
The v function? We have to use the v function to find acceleration by differentiating it. And so our v function was 20 minus 10t. So we'll just differentiate that again. The 20 is going to disappear. That's t to the first, so negative 10. So a is equal to negative 10 meters per second squared. There is no variable, right? So there's no place to put a t. Okay? So what does that tell you? That it's always what? Yeah, because think about what happens. When you throw a stone, the fastest it's going to go is right then when you throw it, right? After that, it's just going to have drag on it, friction, it's going to slow down. Yes?
So when you are working out acceleration, do you differentiate it to get velocity and differentiate it again?
Exactly.
Oh.
It's just the second derivative of the h function. You bet. Okay? Yeah, and we'll sum up in just a minute again, too. Okay, let's calculate the stone's maximum height. Okay? To find maximum height, we need to know the time at its maximum velocity. Okay? So maximum height is equal, we first have to have the time at maximum velocity. which means the velocity equals 0. So first do that part. Do velocity equals 0.
What's the first after max height? What's
Equals
after that?
T.
t.
T. Okay.
There you go. Good. All right. I'll try to be better. It's hard. It's not easy to write on these things, but and I haven't done it in a while, so I haven't taught a math class in a year, so been lazy. Okay, 30 seconds. Okay, you've done it. So tell me what then? What is the formula then? What does time equal if the velocity is 0? Okay, anybody? Pardon? 2 seconds. So we did 0 equals 20 minus 10t. We're solving for the t, so we'll add the t to both sides just to get it positive. I could just as easily have moved the 20, but not by adding, by what? Subtracting. Good. You do the opposite always. So that gives you 10t equals 20. Dividing both sides by 10 gives us t equals 2. And of course, time is always measured in seconds. So that means that it reaches its maximum height, maximum velocity maximum height at 2 seconds. How then can I find the actual height? Get back into the h function, you bet. Which was h equals 2 plus 20t minus 5t squared. If you haven't already, go. 30 seconds to figure that one out for me, please.
Okay. Do you have to minus the 2 off, or is it because it doesn't say change in height?
Maximum height? Okay, we'll talk about it. Okay. About 10 more seconds. Okay? All right? So all we're going to do is, everywhere there's a t, we're going to put what? 2. So 2 plus 20.
Bracket T.
2. You're good. 5 times 2 squared. Too many 2s. That's a lot of 2s, yeah. 2 plus 40. So that's, yeah. 2 squared is 4 times negative 5 is 20. And that gives us what? 22 meters. So the maximum height was 22 meters. Now, do I now need to subtract the 2 away from there? No, because this time, guys, this time we're not worried about subtracting away the 2 because I want the highest point that it reached, right? So I don't want it. I don't want to subtract out anything because it still had those 2 meters in it when it was at its highest point, right? You had to subtract out the 2 meters when it hasn't moved any. Yeah? How far it's moved. Okay, what was the velocity of the stone equal to 12 meters per second? When was that? I'm sorry. So it's a when question, so we're looking for what? Time. Okay, so we know a velocity, so we know that we're going to be using not the h function or the a function, but the what? The v function, which was what? 20 minus 10t. Okay? Plug in the 12 in place of which thing? The v. Go. Get me an answer, somebody.
0.8.
Whoa.
0.6? Okay, maybe it was 0.6.
Subtract the 20. Divide both sides by -10. I hate that, but okay. And that gives us t equals what?
0.8.
0.8 seconds. Excellent. Okay, now, your homework is going to be very similar. Velocities, acceleration. Some of them have all of these. Some of them don't have as many parts. Okay? So what I want you to do for your homework is simply finish that section. So do number 2 through 5. And there's several parts.
So what page is that?
Okay?
Is that unique?
We meet again tomorrow?
Yeah.
I don't see any reason why you can't bang these out before then, yeah? No?
I will attempt it. Do you know what page?
Give it a shot. It's the best you can do. So that's on page 69 through 72. Numbers 2 through 5.
Thank you.
Right? Thanks so much.